Hello physicists, what's the crack? So I've had some questions asking, could we do a bit of circular motion? So let's say here we're going to orbit that takes 30 Earth hours. So circular motion is a topic on AQA that's on paper 1, but if you're in Edexcel or doing OCRA, it's like spaced out in different places. So you either did this at the end of year 12 or it's upcoming for you, or if year 13, sometimes teachers are behind and they start teaching it at the start of year 13, which is a bit annoying because it means you're a bit behind, but at least you have these videos. Just comment below if you need any more help. And we've got our online classes if you want to join. So an orbit takes 30 Earth hours. So for example, here's my planet Earth, and it's some satellite that's going to be in orbit around the Earth, and the time there is going to take 30 hours. What's the guy's angular speed? So what we know is this satellite, if I looked at its linear speed is always at a tangent to the circle. Same way if you had a ball and a rope and you spun it around and you let go of that ball, it would always fly off at a tangent to the circle. So you just imagine there's a ball and a rope spinning around. And again, if you let go of the rope at this point, it would fly off at a tangent. If you let go of the rope at this point, it would fly off in a tangent. So that linear speed is the speed that we've always been using the whole way through physics. The angular speed is exactly what it says. It's how fast it goes through an angle. So let's say that's the center of my circle. When I think, how fast does it take to go around that angle? There's my angle there. So again, we're looking for the speed to sweep through that angle. So the angular speed, okay, so the angular speed we represent with this lowercase omega. So it's just a W, but it's a lowercase omega, and omega is a Greek letter. So you know, like capital omega is that one for resistance. So this is just a lowercase omega. The angular speed that represents angular speed is the angle it goes through for the time it takes to go through that angle. Okay? So let's say we know that an orbit takes 30 hours. So one orbit is the whole circle. Okay? So the angle it goes through then, that whole circle, is 360 degrees. But angular speed is always measured in units of radons per second. Right? So this angle has to be in radons, times in seconds. 1 over time is seconds minus 1. But this angle needs to be in radons, not degrees. And I know that 360 degrees is 2 pi radons. So what I'm doing now is the angle it goes through is 2 pi radons. And the time it takes to go through that full circle, that full orbit, it told me was 30 Earth hours. So I know that time there is going to be 30 hours. But again, I know the unit is radons per second, so it can't be in hours. So I know 30 hours. I know there's 60 minutes inside 1 hour. And I know there's 60 seconds inside 1 minute. So all I do is 30 times 60 times 60 to see what that is in seconds. So it becomes 108,000. So now all I have to do is 2 pi divided by that answer. So my calculator doing 2 times